Yeah, hello everybody. Can you hear me? I'm typing, writing a message. Yeah, Shant Sahu typing. Hello, good, good, good. Now go ahead. All right. Good evening here. Good afternoon. Good evening here. And welcome to all. My name is Pramod. This is my brief introduction, and this is my first class to you. Right. So I'm I'm teaching this course on fundamental of petroleum explorations. This is a brief biodata of my background. So this is the name, which is Pramod Panuli. I worked with the oil and gas industry for many years, both in India and abroad. Since the last 2.5 years, I serve as the professor of oil and gas in the Department of Energy Management in the University of Petroleum and Energy Studies. Formerly, I worked with ONGC. I was the chief geophysicist. So the profile is upstream. Upstream means my core strength is finding oil and gas deposits, exploring and producing oil and gas. I worked for Reliance Industries for a brief period in Mumbai, and I was heading their overseas assets, oil and gas assets. I worked for a company, a Spanish company called Repsol, the Spanish company. It is based in Madrid, so I was located at Madrid for about 6 years, and I was involved in their exploration assets in West Africa. And then for a brief period, about 3 to 4 years, I was based at Houston in their office, Repsol office, working largely in their South American assets. I'm an active member of the professional societies to which I contribute. So I'm very pleased to run this course for you guys. Any questions, just let me know. All right, so the idea is we are talking about oil and gas. Sorry, just a minute. All right, so this is the title of this course, which is Fundamentals of Petroleum Explorations. You can see that I'm going to talk on fundamentals, give you a brief overview of how we explore the petroleum, which is essentially the fossil fuel, which could be oil, which could be gas. So as we know that petroleum, particularly oil and gas, especially oil, this has been dominating and will continue to dominate the energy markets globally as well as in India. Oil, its share is about one third in the energy sector, energy markets, oil itself, and every year, though there is a thrust on finding alternative sources for energy, especially the renewable energy resources, especially wind and solar. But the data shows that the consumption of oil is continuously increasing globally. The share of oil is continuously increasing in the global energy consumption, in the energy basket. So we are adding almost 1 million barrels of oil a day, a demand since the last few years, since 2010, right? Can I see the share box in case there are any questions? All right. So that was, I was trying to explain you the title, which is what it means to all of you. But the idea is when we talk petroleum, then we essentially what comes to your mind is the oil and gas. So the oil and the gas, right? But of late, if you see, if you guys are based in India, some of you, you will see that India India depends on all imports to the extent of about 85 to 86% of our demand is met through the import of crude oil. Okay, so if you look at the 2018 numbers, 2019 numbers, we have imported almost 212 million tons of crude oil and plus the petroleum products. So put together the petroleum imports, which is crude oil plus petroleum products, they constitute a very large number in terms of our foreign exchange revenue. So we spent almost $146 billion on our imports of crude, petroleum products, crude plus petroleum products. All right, so this course is designed because this is the fundamentals of petroleum exploration, which means oil and gas. So it is the course is designed in a number of blocks, and you can see in each blocks there are units which I'm going to talk on. So probably we'll try to cover as much as we can today, and so that we can complete this course in the timeline that is given to us. So one is we start with the introduction of petroleum explorations, how we explore petroleum, which is oil and gas today. What is the petroleum all about? Nature of the petroleum, oil and gas. You will see some of the physical properties of petroleum, how the petroleum exploration licenses are awarded, especially it's a very well defined system of award of contracts. So the idea is you have, first of all, let me make it clear that, for example, in India, all the mineral rights, mineral means anything that is found below the surface of the earth. So the oil and gas petroleum is also a type of mineral, like any mining. So we do any mining, subsurface mining. So if you mine coal, for example, or if you mine diamond or the uranium materials, so the rights to the minerals which are lying below the surface of the earth lies with the state, which is the government of India, for example. Whereas if you go to US, it's slightly different. That if I drill a well within my plot, within my land, and I found the oil reserves, they are owned by the owner of that land. So that's but in large part of the world, the rights to the subsurface minerals, which includes oil and gas, rest with the state. And the state is, because oil is a commodity which can change the entire energy outlook of a country. So oil is a very big resource in that sense, because it brings a lot of revenue, to the government. It brings a lot of jobs. It brings a lot of capital into the country in case there is a oil and gas find. And maybe sometimes we'll see that how the companies, how the countries which are largely or relatively unknown country. We don't know Mozambique, for example, or Guyana today. They have established, they have found very large volumes of oil and gas, and that's going to change the whole economic outlook of those countries. So it's very vital for any state or any country to exploit their oil and gas resources. But to do that business, because you don't want to do it by yourself. Now you can do it by yourself, but as I would like to explain to you, that the oil and gas business is very capital intensive. So the state by themselves don't want to spend the cash, the money into these capital expenses for finding oil and gas, and therefore the companies, the private sector companies or the multinational companies get invited into our license areas, like in India, license areas, and try to run their programs and find oil and gas, which is owned, because as I said, state has the right on the mineral resources, but then we get into a contractual agreement with the contractor, with the investing company, which is investing in India, for example. And then under that agreement, which is known as the new exploration licensing policies, this clearly defines the sharing agreements between, or the modalities and the revenue sharing agreements between the state and the contractor. So these are some of the ones probably we'll try to complete today, and then as we go into the next modules, which is block 2, block 3. So if you can see that total number of blocks are about there are 5 blocks, and we go through the entire project cycle of the oil and gas exploration. All right. So here are few things here. When we say, I'm going to introduce you to the petroleum explorations, petroleum itself first, and then we'll see how that we'll talk on the techniques, how we find oil and gas. So part of the unit 1, petroleum, types of petroleum, and major task in oil explorations. All right, so as you know, the petroleum, for example, okay, right. Just give a minute. I think this is, yeah, right. Goes on. Okay. Petroleum is Petra. Petra is the name of is a Greek term. Some of you must be aware of. Is a Greek term. This is Petra means rock, and oleum means oil. So it's a Greek term which means it is a rock oil. It is a petroleum. It is a oil from the rocks. What it means is the crude oil or the petroleum is always found within the rocks, within the earth. So it is generated. It is generated. How it is generated? It is also known as a fossil fuel. Fossil means because the oil and gas or the petroleum is generated from the fossils of plants, ancient plants and animals. All right. So what constitute the plants and animals? The fossils, it constitute the organic matter. All right. It's decomposed organic matter, which over a period of time, which runs into millions and millions of years, because it gets buried deeper, more and more sediments get deposited. And under certain pressure and temperature conditions, this organic matter, this organism or organic matter, part of that is converted into petroleum. And as you know, the petroleum is lighter than water. Its specific gravity is lighter than water. So it floats on the surface of the water. And because it's lighter, it travels upward from underneath the earth where it is generated. And then it travels upward into the earth and therefore gets somehow located, trapped in certain situations, which we can find by the technological methods or geoscientific methods. And therefore, we go ahead and drill that area, drill that trap, and extract, bring out, and produce the hydrocarbons. So the petroleum occurs in the earth, inside the earth, in combination of any of the four states. So when petroleum is a broader term, but it could have four. It can exist in four states. It could be liquid, which is just the crude oil. It could be just the gas, which is a natural gas. Natural gas. You see today, the whole focus is on gas today. What? Because natural gas is a very clean fuel. It has much higher energy efficiencies, and it has very very small footprint in that sense. But because natural gas is clean fuel, and especially under the Paris Accord, we are committed to bring down the carbon, and therefore every government, including the government of India, has policies which give more emphasis on the use of gas in power generations. So many of the power, 1/3 of the power generations would be from gas. Natural gas would be substituting the oil and the coal which pollutes the environment. It could as well exist in semi-solid, all right? Or the petroleum can also exist as a solid. And you must have heard many countries which are mining petroleum. So when you're surface mining petroleums, you go to Canada, for example, you must have heard of the term like oil sands in Alberta, Canada, right? Alberta. So what are they? They are solid petroleum. The petroleum is mixed with sands, right? So it's solid, and the only issue would be it's not flowable because it's so viscous. It cannot flow by itself. It's semi to solid, and therefore you need very special techniques to extract petroleum from these kind of resources. So that's a different issue. But right now I'm saying that it could be crude, it could be gas, it could be semi-solid and the solid. Chemically, petroleum is a mixture of carbon and hydrogen. Primarily, it's carbon and hydrogen. Mostly carbon and then hydrogen, followed by oxygen. And there are a number of impurities which are found along with the petroleum, which could be nitrogen, some amount of sulfur as impurities, with some traces of heavy metals. So what is the history of the oil and gas? So the oil and gas, it's not that the oil and gas is found only in the air. When the first oil well was drilled in Pennsylvania by an American guy whose name is E.L. Drake. So the history if you go through the literature, you'll see that people have been using petroleum because they didn't know how to extract petroleum at that point of time, but they have been using the oil which was found on the surface of the earth. It was flowing on the surface of the earth. In a way, they were mining oil, you see, mining oil. So there were no techniques at that point of time. But the earliest known oil wells were drilled in China way back in 3rd or the 4th century AD. In the 19th century, so oil fields were exploited in an area around Baku, Azerbaijan, to produce naphtha. So if you see that, and the history is like that, if you so there's a area there's an inbound area in landlocked area which is a very large sea. Sea is a lake actually, but it's landlocked. Is known as Caspian Sea. Caspian Sea, right? And there are all the countries which are all around Caspian Sea are a number of countries, including Iran, Azerbaijan, Kazakhstan. These are all the countries. So it's one of the though it is not sea, it's land, but it constitutes very large amount of petroleum today. And if you go through the, if you go, what I'm saying is, if you heard the name of Marco Polo was a Chinese explorer in that sense, because he came to India from China, and the route that he followed was through Persia. So Iran is bordering uh, Caspian Sea. So he came through Baku, Azerbaijan, Baku, into the India, and then he writes in his stories that while passing through that region, he found that there were large tankers, large vessels, large geysers of oil and gas. So they were coming out of the ground, and people were filling the tankers, storing that oil. So it was all the natural oil which was coming on to the surface of Earth. The first commercial oil well was drilled in Romania in 1857 at Bend, north of Bucharest. All right, so I think this slide got mixed. Anyway, so the idea is most of the oil was first oil well and was drilled in the United States, which drilled 69 feet deep, and in Pennsylvania. And this is a guy. This is a famous guy because whenever we talk about oil wells, this is the name which is referred to as. His name is Colonel Edwin Drake. The first oil well actually was drilled in 1859 in Pennsylvania by E.L. Drake. Coming back to India, for example, so the India, if you heard 1869, we drilled the first well in Assam, in an area called Makum, which is near Big Boy. That's where the first oil well was drilled. And why we drilled that first? We didn't have the techniques to discover oil and gas, but there was oil oozing out of the ground in that area. All right, so there was an oil pit. There was a pit which was full of oil, and that is how the geologists knew that there seems to be some oil which is trapped under the earth, because it is coming out all the way to that pit on the surface of the earth. And this is how all the oil and gas were found during ancient times, because there were no techniques to find oil and gas reservoirs. So the only way the oil and gas wells were drilled at that point of time, which were all very, very shallow, few hundred feet, right, by conventional methods. They are all based on the fact that they have found oil seeps. This is called oil seep, SEEP. Oil seeps. Oil seeps are the oil which comes out of the ground. Out of the ground, as I said, oil is lighter. Oil is much lighter than the water, so it always moves ahead of the water, on the top of the water, and therefore it finds some cracks, some discontinuities within the earth, within the rocks, where it is stored, and from there it travels and it finds this pathway and it comes all the way to the surface. That is how the oil has been found. But commercially, when you say that commercially, means we started exploiting oil from the time which is when the first oil well was drilled in Pennsylvania, and then in the history of India, for example, first oil was when we drilled in Assam, Big Boy, and today we produce about 1 million barrels of oil a day, India, right? What India needs, India's consumption of crude oil is about 4 million barrels a day. So you see, we still have to import more than 3 million barrels a day, and we are only 20-25% self-sufficient in oil. Whereas in case of the gas we are slightly better. We produce almost about 50%, we meet almost 50% of the need of our natural gas today. But as I said, there is a big emphasis on the gas as an energy resource, right? So we are going to increase our share of gas, which is very, very little today compared to the global average. Global average. Our share of gas in the energy mix is about 9%. Is about 9% today, on against an average of about 25% globally. 25, because gas is a very clean fuel, and therefore we intend the new government policies, the new focus on the use of gas, increase the use of gas in the energy mix. So take it from 9% today to 15% by 2025. So that's the target that we have. This picture, what I'm showing you is, I'm a place called Dehradun. You see, Dehradun is also the headquarters of the Oil and Natural Gas Corporations, which is our national oil company, and it has a very beautiful oil museum. This is a very unique museum in Dehradun. I have not seen this kind of museum anywhere in the world, not even the US, not in Australia. So it takes you through the journey of the entire oil and gas exploration in India, you see. And you can see on this slide that various gas samples, you see oil samples right here. These are the samples which are collected from the different oil fields that ONGC has drilled or ONGC is producing. Okay, this is in case you happen to visit Dehradun, you must pay a visit to the ONGC museum. It's free, and it's free for all. Anybody can go there. All right. So as I said, petroleum is organic, right? So there are concepts. There are people think whether they are contemplating whether the origin of petroleum can be inorganic. But for now, I'll say that petroleum is organic because it is generated from the fossils of the remains of the plants and animals. So it's the organic matter. Organic matter is the key word. Organic matter, which is transformed into petroleum. It contains complex carbon-hydrogen molecule structures called chains that are linked together to form the long chains complex molecules. For example, methane. Methane is one atom of carbon, one molecule of one atom of carbon, and 4 atom of hydrogen, CH4. So this is CH4 is known as methane, is one such hydrocarbon. Now, if you look into this picture, you can see that these are the you can also characterize the crude oil by its appearance. The thick crude oil, because thick means it's more viscous, its viscosity is high. It doesn't flow freely. Thick viscous oil is more black. You can see that it's dark black color. As the crude becomes lighter, it becomes less viscous. It has more flow characteristics, rheological characteristics. Flow, it can flow free flow through the pipelines. It's lighter. Its color also is lighter, and it's very light crude oil. Light crude oil. You can see it's very light. Very light. I'm going to explain some properties later on, but this is by the this is the physical appearance of the crude oil. And as I said, petroleum can also exist in the solid state. So this is the petroleum in solid state is like a rock by itself, chunk of rock, which is, if you look at us oil sands, you'll see it's like a chunk of rock. It's a solid state at room temperatures. All right. Crude oil refers to the liquid petroleum as opposed to crude oil. All right, so I'm going to close this guy here. Crude oil refers to the liquid petroleum as opposed to the refined oil. Okay, so we'll see. I'm going to discuss the three main segments of the oil and gas business. But right now, I'm talking more on upstream. The crude oil refers to the liquid petroleum as opposed to the refined oil. There are liquid hydrocarbons that contains varying amounts of dissolved gases, bitumen, and other impurities. In raw state, the crude oil resembles ordinary lubricating oil, and that is what my last slide was showing you, how it looks like. As I said, the crude oil is immiscible with water. It doesn't mix with water and has a density which is less than that of the water, and therefore crude oil is always on. The crude oil always floats on the column of the water. So when you find oil and gas in a pool, oil and gas pool, oil or the petroleum pool inside the rock, you'll see that the petroleum is only contained in the top part of the trap, and the bottom section would be water. So it's a water drive, So it's getting the pressure of the water from beneath. So it's a closed system. It's a closed system because oil cannot escape. That's how we find it within the earth. We drill into an area where it is a closed system. That means the oil and gas is trapped. It cannot move any further, any upward. And you got a water system, water driving from beneath. So it's a very high pressure system, very high pressure system, closed systems, and therefore it's very risky to drill. So you have to take adequate measures. You have to do all the analysis before you drill the oil wells. Crude oil, however, is soluble in certain solvents like naphtha, carbon disulfide, ether, and benzene. On the other hand, the natural gas is a petroleum gas. When you say the natural gas is also from the plants and animals, which is the organic matter, and distinguished from the manufactured gas, which is like your LPG, right? Natural gas consists of the lighter paraffin hydrocarbons, which are the hydrocarbons of the methane series, and most abundant being the methane gas, which is CH4. Semi-solid and solid forms are called heavy hydrocarbons like bitumen. So I'm going to show you the next slide. You'll see how we classify the petroleum or the crude oil. They comprise materials such as asphalt and tar, albertites, or any number of names depending on their characteristics and local use. Natural gas is petroleum gas as distinguished from the man-made gas. Like this I already said, so I'm going to repeat that. So chemically, if you see the composition of crude oil, it's mostly carbon and hydrogen. Carbon is about 83 to 87% of carbon. Hydrogen constituent is about 10 to 14%, and nitrogen, a little bit of nitrogen, 0.1 to 2, oxygen the same, less than 2%, and sulfur. Sulfur is a big thing, sulfur, because sulfur is the one that makes crude oil, either it is a sweet or it is a sour. And why I'm saying the amount of sulfur contained in the crude oil, sulfur and wax, this determines how this crude oil will be processed. It cannot be processed in every refinery. Refineries are the places, you see there are many refineries. In India, for example, all the downstream companies, IOCL, BPCL, Reliance Industries Limited. So they are the downstream companies. That means their business is refining and marketing of petroleum and petroleum products. And they take all the crude oil from the upstream companies like ONGC, or they're importing that crude oil from abroad, right, from Middle East, for example, and they're refining that into their refinery. So every refinery has the specifications which cannot handle every type of crude oil, though the modern refineries today can handle any type of any mix of crude oil. The component of crude oil can be classified into two hydrocarbon series. These are the two series. If you see, okay, I'm going to take this further so that you can see this. All right, so now you can see the whole picture. So into two hydrocarbon series. So primarily we talk about two hydrocarbon. When we say petroleum classifications, there will be two hydrocarbon series. One is known as methane series, methane series, which is also known as paraffins, methane series, and the other series is known as naphthalene series. Crude oil belonging to the first series, which is methane series, is also referred to as paraffin, or we say the oil is of paraffinic affinity, paraffins, methane series. Paraffins, because they are chemically different, the chemical structure is different. Paraffins are straight chain hydrocarbons having a general formula of CnH2n plus 2. That means when n is equal to 1, it becomes CH4. So the four principal types of paraffins or the methane series hydrocarbons are methane first, because it has one atom of carbon and 4 atoms of hydrogen, and the next would be C2H6, ethane, propane, and butane. So these are all gaseous forms, with each heavier molecule adding one CH2 molecules to the preceding compound. On the other hand, another type of crude oil belonging to this series is naphthalene. It contains carbon ring compounds having the formula of CnH2n. So these are also known as cycloparaffins. So the methane series is paraffinic, whereas the naphthalene series is also known as cycloparaffinic. Cycloparaffins, with the most abundant being the cyclopropane, which is C3H6, and cyclobutane. However, the molecular structure for this group of hydrocarbons can contain long branch chains with complex rings as high as C30H50OH. Of the two types of crude oils is the paraffinic oils or the methane series, methane series of oil, which is the most price. It fetches more value, more economic value, more market value, but it comprises less than 2% of the total world supplies. Crude dominated by naphthenic components are called asphalt-based oils. About 15% of the total world supply is of this type, and it is also known as the black oil. So these are the molecular structures of the hydrocarbons, the two series. When you say methane, so this is methane series, which is paraffinic, methane, propane, ethane, and butane. Vast majority of crude oil are a mixed base of paraffin and naphtha. Because why I'm saying it, because petroleum is being generated from the fossils and the plants and animals which are which have different organic matter types, right? Petroleum is found in different parts of the continents. Petroleum, large part of petroleum is found in Middle East, for example, right? Middle East. So you see the Persian region, OPEC, Organization of Petroleum Exporting Countries, OPEC nations. So they dominate, they control the crude oil markets because they have a they have a it's a basically it's a consortium. OPEC is a member nations who control large source of petroleum in their nations, and therefore the supplies of crude oil or the petroleum depends a very large extent on the supplying capabilities, supplying abilities of these OPEC member nations. Many of these OPEC members are from the Middle East. The largest contributor of oil within the OPEC nation is the Saudi Arabia. Saudi Arabia holds the largest number of petroleum reserves. Right? They are the largest, the highest, the biggest supplier of crude oil worldwide, right? So the natural gas. So what I'm saying is because this formed is found in different parts of the continent, and therefore the characteristic of the crude oil, they also differ globally from one place to the other. In India, for example, if you talk to India, all where we find petroleum in India, we find petroleum in land. In land, we find the first oil wells, such as first oil fields were found in Assam, for example. Then we found the next we found most of the petroleum in in Cambay Basin, in a basin which is in Cambay. Cambay is near Gujarat. Gujarat. You heard of Ahmedabad, Mehsana. These are the areas. Kalol, Balol. These are the areas where the oil is produced. Petroleum, very large petroleum province. And then you found very large oil and gas deposits in sea, offshore sea, away from the land, which is the Mumbai High. So when you travel from Mumbai from the coast is about 100 kilometers, 100 kilometers into the sea. There's a very large field of petroleum, oil and gas, which is known as Mumbai High Field. Mumbai High Field is the only field which is which is which goes into the classification of a giant field, because it holds, it held, because now we produce a lot of oil and gas from Bombay High, but it was holding 500 million barrels of oil in place. So it's the only field that qualifies as a giant field in India. And then you find, but it's very light oil, you see, because it's offshore, right? It's very light oil, it's very sweet oil, and therefore it fetches a lot of market value. If the oil is harder, if it is not sweet, if it is heavy oil, it fetches much lower market price, right? So the market price will depend on the characteristics of the crude oil. But then, because oil is being produced in different parts of the world, so there has to be a system. There has to be a system of benchmarking the crude oil in terms of its economic value. That's very important, because what price my oil can bring, it has to be benchmarked. So is benchmarked today, and I'm going to explain that how it is benchmarked. It is benchmarked on the criteria of the API gravity. So we'll see that on this slide. I think I'm going to complete. Natural gas consists of hydrocarbons not condensable at atmospheric temperatures. Natural gas, when you say natural gas, means it remains in the form of a gas at at atmospheric temperature and pressure. Natural gas comprises mostly the first four members of the Paraffin series, which is methane, ethane, butane, and propane and butane. If the natural gas is composed of entirely methane, there could be a case that you just have methane into the as a whole energy, or as a whole gas system as methane. It is referred to as dry gas, methane. So whenever you heard the dry gas, you should know that we are talking of methane. But if it contains ethane, which is the next higher molecular structure, C2H6, ethane, content in methane exceeds 5%, it is referred to as the wet gas. So these are some of the terms which we use sometimes, dry gas and the wet gas. So we should be aware of what it means. All right. So three distinct types of natural gas based upon their origin. So why the oil and petroleum is different? Because their origin is different. It is generated by different family of organic matter, which are plants and animals. You go to some part of the continent where there are rainfall, heavy rains, heavy. But I'm saying you should also know that the oil and gas, petroleum that we are exploiting today is not generated today. It is generated millions and millions of years ago. Maybe 60, 70 million years ago, this oil, this petroleum was generated, which we are extracting today, right? So it was deposited, the organic matter was deposited, it was fossiled, and then it got buried deep into the earth. It took millions and millions of years to attain the required temperature and pressure conditions under which the part of the organic matter can be converted into petroleum. Right? So that's the petroleum gas. Many times, some of the gas is dissolved within the petroleum, within the oil. So there could be a free gas, as I said, which is free, and then there could be a dissolved gas. That means a large amount of gas is dissolved in the liquid at reservoir conditions when they sit under the earth. But once they are brought out to the surface of the earth, the gas which is dissolved into the crude oil, escapes out of the liquid, and therefore the volume of the oil will swing. Volume of the oil will swing because the gas will escape. Okay, so this is known as the dissolved gas and the free gas. Then there is another type of gas which is known as coal gas. I don't know whether you heard of the coal bed methane. It's mostly methane because it is generated from coals. It is not being generated by the organic matter I was talking about. It is generated from coal. Coal is also a plant. No? Is a plant. It's generated. It comes from peat. Is peat. Coal is from plants. Coal gas is formed by the modification of coal through the heat and pressure and other natural processes. It is a major source of commercial gas worldwide. So the term that we often use is the coal bed methane. It is mostly methane, right? Methane, that means it's a dry gas, methane. And it is found within the coal seams. And it's also a major commercial gas source worldwide. Why it is that? Because some of the countries have very abundant resource of coal. India being one such country. In a very large source of coal exists in India. So is in Australia. So is in China, right? And therefore, we try to exploit this gas from the coal. So there are areas within India. Give you a flavor of this. If you go to Raniganj in West Bengal, Raniganj area, right? Essar Oil is a company which produce almost half 0.5 million standard cubic meter of gas a day. That's their current gas production from their coal seams, and they're going to increase it to the 1 million standard cubic meter a day in sooner or later. Then the third type of gas could be bacterial gas, gas, but it is from bacterial actions. So what happens is close to the surface of the earth, the temperatures are low, all right? So one thing we should know that as we go deeper into the earth, the heat increases, the temperature increases, right? And you need elevated temperatures for organic matter to be converted into petroleum. That means you need the temperatures almost of the range of more than 70 degrees up to 140 degrees temperatures, right? You need this range of temperatures for organic matter to be converted into petroleum. But what happens if you have a very low temperatures? You have temperatures of the range of 30 or 40 degrees centigrades. You are not going to create petroleum, all right? But some part due to bacterial actions, you are going to generate some gas due to the bacterial actions from the same organic matter, and it is known as the bacterial gas. Okay, this is also known as biogenic gas. So the terms that we generally use are thermogenic and biogenic. Thermogenic is the petroleum. Thermogenic actions lead to creation of petroleum because they are elevated temperature. Whereas the biogenic, which is a low temperature phenomenon, low temperature actions, generally create the biogenic gas. It is same as the gas that you generate from the plants, the cow dung, for example. So this is methane. This is primarily methane. It is by the bacterial actions. So the organic theory of crude oil is, this is organic theory. If you see that, crude oil, how this picture gives you some sense of what's happening, how we are creating, how we are generating petroleum. So if you see, I'm going to use a term which is planktons. Crude oil is formed over millions of years ago from tiny aquatic organisms called planktons that lived in ancient water bodies, mainly seas. So these are the seas right here, right? So they are the planktons. We call planktons. What are planktons? Planktons are tiny organic matter, organism. They are the lives. They are the lives that thrives within the water bodies, like the sea, the lake, and the sea. Right? So they are organisms, aquatic organisms. They float on within the water. But these planktons, the problem is these planktons, which are the floating organisms, they cannot swim. against the current. Again, whenever there are currents, and there are plenty of currents in the sea, they cannot swim and they die. So once they die and then drop to the surface of the lake or the sea. So you can see it here. So they are the planktons, right? So they die because of the currents, and they fall to the ocean floor. So this is the ocean, for example. See, you got an ocean floor, right? So you have a water column, and the base is the ocean floor where the sediments start, where the rock starts, where the deposits are, first deposit occurs. So they get deposited, floor, they get fall, they get overlain over these ocean floors. And because in the sea, the sediments are coming. Who are bringing sediments? Sediments are being brought by the rivers, for example. So you go to Bay of Bengal, which is the mouth of at the Hooghly, which is the Ganges. The Ganga is traveling all the way from Himalayas, and therefore it is bringing with this water, it's bringing tons and tons of rock, debris, rock. It is eroding the earth, it is eroding the surface of the earth, right? And then it is mixing those sediments. It's called sediments. Sediments is a mixture of the water and the rock particles, sediments. Along with this, it is bringing lot of plants and animals, and then it is dumping all that into the Bay of Bengal, which is the sea. So it's bringing sediments, and therefore the sediments will be continuously piled up, and maybe these planktons. So you have sediments piled up, right? Piled up, and you will see that it will be overlain by say 3 kilometers of sediments over a period of time. So I'm saying that if these organic matter is deposited 50 million years ago, from 50 million years today is the zero. The present time is the zero on geological time, zero. You have deposited almost 2 to 3 kilometers of the sediments. 2 to 3 kilometers of sediments are deposited. That means the sea floor would be somewhere here today. Current sea floor would be here today. And then for this 3 kilometers of sediments overburden is exerting lot of pressure on these organic matter. And the temperature also increases, right? From the sea, at the seabed, if you see seafloor, the temperature would be about 4 degrees centigrade. But go to the 3,000 meters into the earth, deeper into the earth, the temperature could be elevated as 70 to 80 degrees centigrade, or maybe higher, right? And a lot of pressure and temperatures. That is how this organic matter, which is brought by these planktons or the fossils, part of that is converted into petroleum. So that's how the petroleum is, the organic theory explains the generation of petroleum. So once it is generated, petroleum, it is going to escape from the rock, out of the rock where it is deposited. Why? Because it is lighter than the water, lighter. So if there is no oil, it is water into the sediments inside the rocks. So because it is lighter and it is pressured, it comes with the pressure, and therefore it travels upward. So if this is my source rock, what is the source rock? I'm going to explain later on. The source rock is the one that contains organic matter, and therefore it generates petroleum. It creates petroleum. So if you go to an area for exploration of oil and gas petroleum, you have to make sure geologically, conceptually, or technologically, you have to be sure that you have adequate source rock in that area. If there is no source rock, there will be no petroleum generated in that part of the world. So the first thing is when you go to explore petroleum, you have to make sure that you have the adequate matured source rock in that area. I'm going to explain that later on. Source rock. So this in the case that the source rock has generated petroleum, is going to come out of this rock. It's going to travel wherever it finds ways, and then you find a closed system. This is the closed system right here. What is a closed system? Closed system is, this is a kind of a structure which is created by one of the rock. So this rock is we call it a sealing rock. It's very, very fine grain rock, fine grain, and therefore nothing can pass through this rock. It is a sealing rock, okay, sealing rock. And then you have the reservoir rock. Reservoir rock is nothing but the sands or the carbonate sands. Sands means it's like a reservoir where the fluid can be stored. So we have a reservoir where like we store water in the reservoir, right? Same is the case with the oil or gas. So we need a rock which has lot of space in between the grains, So these are the grains, like sands, and there's a lot of void space between the grains where this petroleum, which is generated and move out of this rock and travel and fill this space. That means there is adequate porous space for the oil and gas to fill or trap, and then it is overlying. It is overlain by a rock which is completely a sealing rock. So it's not going to let this oil and gas which is trapped here get move any further. So this combination of the source rock, the reservoir rock, and the cap rock is called a trap. This is called a trap. So in oil and gas explorations, all the techniques that we use today are meant to locate or find such traps where the oil and gas can be found. So this is a very simple concept of a trap. So this is one type, very simple type of trap. Most simple type of trap, which is a structural trap. So this is a structure trap, which is, and all the early oil, whether in OPEC in Saudi Arabia or even in India, worldwide, was found in these type of traps. They are simple traps, simple definition of traps, very, very simple to know. All the early oil has been found in these type of traps, which were much easier to be located. But today, the situation has changed because all the easy traps have already been found, and therefore the challenges today for oil and gas companies is to find oil and gas which do not reside in the simple structural traps, which are more complex, very, very complex traps today. And many of these complex traps are in the deep water. So we just get reminded that when I'm saying deep water, means sea, but the deep sea where the water depth could be more than 2,000 meters water depth. You see Bay of Bengal, you see the Reliance discovery in KG Basin, which is a Dhirubhai Ambani field, D6 field. And that's the deep water. ONGC's discoveries in deep water, KG Basin, Krishna Godavari Basin, and the Kaveri Basin. These are the basins where large potential of oil and gas exists in deep waters. Worldwide, deep water exploration is happening. Is most of the companies, they are finding very large petroleum reserves from deep water areas. So that is where the technological challenges exist. But thanks to the technology today, and it is evolving. That means Technological innovations are allowing us to move deeper and deeper in for oil and gas exploration in sea, right? So the crude oil classifications, if you see, so this is what I was saying, and I made a statement that because the oil and gas petroleum is found in different part of the world, and therefore there has to be some benchmark in getting its market value, in market value. So how we are going to classify the crude oil? So this is how it is. One is the crude oil is classified by where it is found on the earth, in geographical locations where it is produced. So you can see the Middle East crude, or you can see the Canadian crude, or you can see the Latin American crude, or you can see the Indonesian crude. That's the geographical location. This is one. So I know roughly, okay, this oil comes from Persia, Iran. This is Iranian oil, or it is the Saudi Arabian oil, OPEC countries oil. But the most critical thing is, most important parameter that is used worldwide to benchmark the crude oil for its market value is the API. What is API? API is the American Petroleum Institute. API gravity. So each crude oil will be calculated for its API gravity value. API, and there's a formula. I'm going to show that. And therefore, depending on its API number, API gravity value, the market price of the crude oil will be determined. We remember that this API gravity is inversely related to the density of the crude oil. That means the more dense the crude oil, the lower the API gravity value. When I'm saying higher API gravity numbers means the oil is much lighter, much lighter. The lower API gravity number means the oil is more heavy, more viscous, more heavy, and also the other would be its sulfur content. So this is the geographical location. You can see that. So you can see somebody will say, okay, this is the Canadian oil, Canadian provinces, Canadian oil. This is all the North American oil. Okay, all right. You can see this is the OPEC, Organization of Petroleum Exporting States, member states. You can see the one in Venezuela in it, and you can see most of that are in Middle East, which is Saudi Arabia, UAE, Qatar, the other Iraq, and then you can see in Africa you have Libya, you have Syria, you have Libya, Algeria, you have Nigeria in blue, right? Nigeria in blue. You have Gabon, and then you can see on the eastern hemisphere you can see you have Indonesia right here. Okay, so these are the OPEC member nations, and then you have the North Sea oil states, North Sea. So there are when you check the price of crude oil today, for example, so you'll see the two prices. One would be the WTI price. What is WTI? Is the West Texas Index. West Texas Index is right here, Texas. That's the Texas. This is the Gulf of Mexico right here. Gulf of Mexico. A lot of oil is found here. Gulf of Mexico is one of the largest producers of global oil. Gulf of Mexico, all offshore. But there is a lot of on-land oil in the U.S. and this oil is benchmarked as WTI, West Texas Index oil, right? And the other is the this is from this is the Brent, or this is a North Sea oil, which is a Brent. And you'll see a few dollar difference between the WTI, which fetches higher value than the Brent crude, right? So these are the classification based on the geographical location. But I think the most important is the API gravity. This is the one API gravity. I have to know if I'm saying, because I know the API gravity of WTI index, WTI, or API gravity of the Brent crude, which is coming from the North Sea, okay? So American Petroleum Institute, this found a way. They computed a number, which is the API gravity number, right? Which is a measure of the relative density of petroleum liquid and the density of water at standard pressure and temperature. It is used to compare the relative densities of petroleum liquids. And this is the equations. So when you want to compute the API gravity of petroleum, we have to use this number 141.5, which is a fixed number, divided by the specific gravity of that petroleum, whose API gravity you are computing, minus 131.5. So the number you get is API gravity, and then you look into the table. This is the table, and you will see whether your crude oil is light or it is medium, it is heavy, or it is extra heavy. So the crude oil is classified as light, medium, heavy according to its measured API gravity, and therefore it fetches a, a value, how many dollars per barrel, per barrel, what is its market value, and that is governed by the API gravity number. If it is light crude, for example, light crude oil, and you can see the WTI, West Texas Index, is a light crude oil. So I will know that light crude oil is defined as the oil which is API gravity is higher than 31.1 API. Just keep in mind that API gravity is inversely correlated. Inversely, it has an inverse bearing on with the specific density. That means higher the API gravity, low is the density, and therefore the heavier the crude oil is. So light crude oil, which can flow very freely, is very light, very in color. Its flow characteristics are excellent. It has very less contamination in terms of sulfur, for example, nitrogen and sulfur. So its API gravity would be more than 31.1 API. When you see the medium oil is defined as the one having API gravity between 22.3 and 31.1. And then is the heavy oil. Heavy oil is defined as the API gravity, which is below 22.3 API. And then you have extra heavy oil. Extra heavy oil is defined as having API gravity below 10 API. So it is impossible for the extra heavy oil to flow through the pipeline. Heavy oils, light and medium oil can flow through the pipelines. Right? Even the heavy oil doesn't flow. You need to take extra measures to treat the heavy oil. That means you have to heat that oil. Heavy oil, or you have to mix that oil with some chemical agents to reduce the density of that oil to make it flowable through the pipelines. And one of the example is Cane India, which is also known as Vedanta in India. They found a very large oil field in Rajasthan. If you know, in Barmer Basin, in Rajasthan, that oil is heavy. This oil is heavy because its API gravity is below 22.23, but it's a very large resource. They were lucky, Vedanta was very lucky. Cane Energy is a Scottish company which was bought by the Vedanta group, and therefore it became Vedanta. But they found almost 1 billion barrels of oil in Rajasthan. Very large resource of heavy oil. So they got to treat this oil so that this oil can be brought to the refinery. You need to refine that, right? So they are using a very special technique for this to treat this heavy oil so that it can be transported through the pipeline. But the extra heavy oil, no way. You got to mine that. You got to mine the extra heavy oil. It cannot flow. Extra heavy oil doesn't flow. You got to burn that. And then you have a sweet oil. You also hear this term sometimes, sweet oil and the sour crude. Sweet. What is sweet? Sweet is a light oil which has very less concentration of impurities like sulfur. Sulfur. Sulfur content is less than 0.5% with diminutive amount of hydrogen sulfide and carbon dioxide sulfide. So all the crude oil that comes from Bombay High, for example, is a sweet crude oil. Sweet crude oil, that means it 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 fetches higher market price because the refineries, all refineries can process this, can refine this, right? Much easier. This is this sweet crude oil will be used to generate to to generate very high grade gasoline like the the ATF, which is which is used for aircrafts, for example, which is uh, so if the if if the crude oil is very heavy or very sour, for example, it cannot be used. It's not used to generate gasoline, for example. Okay? It could be used. It could be processed into fuel oil and diesel instead of gasoline. So you can see that the sulfur content, and I give you the example of Bombay High, right? Very sweet oil. Due to low percentage, it has very less percentage of wax. When the wax is less, it has low viscosity, and which facilitates easy pumping and transportation of this oil through the pipelines. Light sweet crude oil demands the highest price in the market, right? And that's the reason you see the difference between WTI price and the Brent price, and you'll find a difference of about $4 to $5 a barrel. On the other hand, the crude oil which is not sweet, which is sour, will have a high percentage of sulfur impurities, more than 0.5%. Okay? It is usually processed into fuel oil, and diesel instead of gasoline. This is the global distributions of the various types of oil. You can see the conventional oil, which is light oil actually, is about 30% in the volumetric proportion, followed by heavy oil is 15%. There is a very large quantity of extra heavy oil on the earth, 25%. You see 25%. And a lot of this extra heavy oil is where? This is in Venezuela, in many countries, where you need special techniques for this oil to be processed, to be transported and processed. And then, as I said, in Canada, for example, in Alberta, oil sands, bitumen, very large percentage, very large fraction of the global resource exists as oil sands in Canada. So therefore, to treat this, you'll be spending more money. You'll have to use technology, which it means you'll have to process this especially, and therefore there'll be more cost to produce this oil, more cost to produce this oil as it becomes heavier and heavier. The top three oil producing countries are Saudi Arabia, Russia, and United States. About 80% of the world readily accessible reserves are located in the Middle East. You know the Middle East, OPEC. So they are the mafia. They control all the supply part of the global supply from the, and therefore the price, crude oil price is also controlled by, to a large extent, by the agreement that the OPEC nations make. You know, they meet every 6 months. They have the meeting. Most of those meetings happen outside OPEC nations, OPEC nations, and therefore they take stock of the demand supply of crude oil, and therefore decide on how much oil the OPEC nation should produce. Every OPEC member has a quota, has a specific quota to produce oil. They cannot produce more than that quota. It is only when the oil price needs to be to be controlled. If the oil price goes down, for example, as has happened in 2012 all the way to 2016, a very bad turmoil period for the oil and gas companies, oil companies, when the oil price became very, very low. It was almost $25 a barrel. It was hovering at $100 a barrel in 2012, and it went nosedive to almost $25 a barrel in 2012 up to 2016. And therefore, the OPEC nations, OPEC as a body, they decided that they are going to cut the OPEC production by about 1.3 million barrels a day. So they are going to enforce the production cut. That means they're going to cut the supply of the crude global oil supply, and therefore bring the crude oil price go up. They're going to help the crude oil price up by reducing the supply side so that the crude oil price improves. So this is the kind of mechanism which the role of the OPEC in controlling oil price. And that's happening because large part of the crude oil supply is coming from OPEC. Saudi Arabia, UAE, Iraq, Qatar, and Kuwait. A large portion of the world total oil is found to exist as unconventional resources, such as bitumen in Canada. You can see that bitumen in Canada almost 30%, very large resource, and Venezuela and shale oil in US. So this is about when you say the petroleum. So petroleum, one is the conventional petroleum. Conventional petroleum is the one oil and gas which can be produced by conventional methods. Conventional method, that means it flows by itself, conventional methods. But then there is another type of petroleum today where lot of spending is going on, and that is known as unconventional petroleum resource. Why it is unconventional petroleum? Because this petroleum cannot be produced. The source is the same, the method is the same, the rock is the same, the organic matter is the same, which is deposited, but this particular petroleum cannot be produced by conventional methods. So you have to use the technologies, the special methods, which are unconventional methods, to produce petroleum from these resources. That means this requires extra amount of investment because it cannot be produced by conventional methods. So what are those unconventional petroleum resources? One of the biggest one that contributed to the enhanced global oil supply since 2010 is the shale oil in US, shale oil. So there are a lot of shale oil that you see US became one of the biggest oil exporter, no? In that sense, because they have abundance of shale oil resource in US. Okay, much more than the petroleum resource that Saudi Arabia has. Saudi Arabia has all conventional resources, but the US shale oil resource are far bigger, far greater than the conventional resource of Saudi Arabia. So therefore, all US emerged on the oil supply market because of the shale oil, and that became possible because of the technology. Shale oil exists for a long time on the earth, but it's very recent, the last 10 years, where the US companies innovated and mastered the technologies to economically exploit the shale oil resource from US. And that's why the two main techniques that I use in shale oil, I'm just giving you a hint right now. One is called the frac, the hydrofrac. You got to frac. So you create artificial fractures you fracture the rock by using high pressure jet of water, which is mixed with sand, okay? And therefore you rupture the rock and create fractures, and therefore you connect the network of petroleum, because shale is very fine rock. Nothing flows through the shale, and therefore you need to frack it so that to develop a network of fractures within the rock. And the second technique is the horizontal well. So all the oil wells have been vertical. So they are vertical wells from the surface, 3,000 meters down, straight vertical hole. But in the shale oil, the technique that is used is the horizontal well. So you drill vertical and then you do lateral, right? That means you exploit the larger surface area, larger drilling area of the shale petroleum. So these are the two techniques which were pioneered, which are innovated by the US companies, and therefore, because they have a very large resource of shale oil, they 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 become pioneer in the shale oil production. Total proven oil reserves today are 14. Well, this number is old. These numbers will have 2018 numbers are different. But you can see that OPEC holds almost 80, 81, 82% of the, the, the world oil reserves, and all other nations, non-OPEC nations, are about less than 20%. And this is the OPEC distributions itself. Is a big. One of the things that for any company, it is important to find any oil and gas company which are into oil and gas productions to sustain into oil and gas business. They continue to find oil and gas more than what they produce. So we always call this number, which is known as reserves to production ratio. That means if ONGC, for example, is producing 1 million barrels of oil a day, it must be able to discover more than 1 million barrels a day of reserves every year. Otherwise, their reserve base will deplete. If they don't find any oil and gas, they are only producing from the resource which is already discovered, right? So for any company, any oil and gas company to remain in the oil and gas business, they continue to find more petroleum than what they produce every day or annually. Okay. So these are some of the ones. You can see North America, South and America. So these are the reserve to production ratios. And you can see this is the continent, South and Central America. You can see they've been able to produce. They have been able to replace 120% of their production. That means they have found if they produce 100%, they have added 120% of reserves. Right? This is the number of 2016 compared to North America, almost less than 30% R&P ratio, Africa, Asia. And then this is what is happening. This slide is also important. You can see that North America, for example, this is North America, green. These are the number of years, and this is the reserve to production ratio. So what happens if you look into the US numbers, for example, US 1990, or all the way to 2006 and 10. Something happened here, in this area. This is the area where there's a lot of shale oil production started. That's why this curve has gone up. South America, Central America, during the last few years, They made very large discoveries, very large discoveries from 2008 onwards, very globally very large discoveries, which have added very large reserves, very large reserves. So this gives you a historic view of how the oil and gas companies are what is the health of the oil and gas companies. Therefore, the it is very crucial that the companies make investment to find new oil, to discover more oil, uh, more commercial oil. All right. So I think we are going to conclude here today on the slide. The time is up. Thank you guys for listening to me. All right. You can send your if you have any questions, just send it to me to on this. Write your questions and I'll come back to you. Uh, I can give my email or whatever it is, and I can clarify any questions that you have. All right, guys. So thank you for your time, and thank you for listening. Okay. Stop share again.